All right, today we're taking on graphing a cubic parent function and then applying some transformations, and then state the domain and the range. So for the cubic function, start with a table. I always go -2 to +2. So then if I plug in a -2 into parentheses and I raise it to the third power, -2 to the third power will get us -8. -1 put inside of parentheses and raised to the third power gets us -1. 0 stays at 0. 1 cubed is still 1, and 2 cubed is 8. So when I start, I usually start by putting my first point at the origin. And then I'm going over 1, up 1, left 1, down 1 to get these first 2 points after the origin. And then to get these 2 from the origin, I'm going over 2, up 8, and I'm going left 2, down 8, just like so. So that gives me this beautiful little squished S-shaped function that is my cubic function. Okay, what's really nice about all of these, no matter when we move it, stretch it, compress it, flip it, translate it, shift it, all of the above, your domain and range will always be the same. It's always going to be all real numbers or from negative to positive infinity. So as I look at the domain, what can x be? It is moving here, growing left to right. It's also growing bottom up. So my domain, all real numbers, also my range, all real numbers. If we prefer interval notation, that's great too. Negative to positive infinity. So again, this will be true for any cubic function. No matter what we do to manipulate it, to translate it, stretch it, compress it, flip it, all of the above, our domain and range are always the same thing. All right, number 2. Here we have a negative out in front. So that tells us this function is going to reflect over the x-axis. Okay, so let me first drop my anchor at the origin. It's reflecting over the x-axis. So if I start with that first point, normally over 1, up 1, I'm going over 1, down 1. So I'm going to put a point right here. That next point would have been down 1, left 1, down 1. So instead I'm going left and up 1, just like that. And then I can see where the other points are going to end up falling, because next I would be over 2, up 8. So here I'm going left 2, up 8, and right 2, down 8, just like so. So I can see that it has reflected perfectly across the x-axis. Okay, and again, my domain, my range are going to be the same for every cubic function. All real numbers here, and all real numbers here. Okay, or negative to positive infinity, if you prefer the interval notation. So I know I keep saying this in all of the videos, but in early years of math, we use the all real numbers notation, or we use inequality notation. And as you move up in years of math, we start shifting and we move into the interval notation, where we define it by our starting value and our ending value, our low to high extreme values. All right, next up here, x to the third power plus 2. So that means that we're taking our parent and we're sliding it up 2 units. So if I started here at the origin and then I moved up 2, my new starting point is now right here, up 2 units at 0, 2. And then from here, I'm going over 1, up 1, left 1, down 1, back to that starting point, over 2 and up 8, puts me right here. Left 2 and down 8 is going to put me right here. And then I connect the dots, and I have my beautiful cubic function. My domain, x, well, x can be all real numbers, can be anything I can think of in terms of the numbers that I've learned so far. So we're only looking at real numbers. So it could be any number we can conceive of at this point. Or, of course, we can say negative to positive infinity. And then up here, I'm just going to make a note that this was a vertical translation or shift 2 units up. So every point from my parent has slid up 2 units, a vertical translation or a vertical shift 2 units up. All right, next one here, I see that it's x minus 2 inside of the parentheses being cubed. So it's inside of the function, not outside of the function. So that tells me instead this is a horizontal translation. And horizontal is the opposite of what it appears. So this tells me that it's going 2 units to the right. So instead of starting at the origin, we're 2 units to the right, right here. And then it's the same as the parent. So over 1, up 1, left 1, down 1, back to that starting point. Over 2 and up 8, puts me right here, back to that starting point. Left 2 and down 8 right there. So here is my cubic function, looks just like so. And again, for any cubic function, domain, all real numbers, same with the range, or negative to positive infinity. Just depends on your preference. It does not matter to me. Let me just box what I got. All right, last 2. So here we see a 2 on the outside. So right there, that's the multiplier on the x to the 3rd power. So that tells us it's a vertical stretch by a factor of 2. What does that mean? It means that all of the y values are getting doubled. They're all getting multiplied by 2. So I'm starting at the origin, just like the parent. And instead of going over 1 and up 1, I'm going over 1 and up 2. So here, and then left 1 and down 2, just like that. Okay, my next points, I'm actually not going to have room for, but I'll mark where they are approximately. So over 2, up 8, usually. That 8 is getting doubled to be 16. So over 2, up 16 would put me off my grid, so somewhere up about right here. And then over 2, down 16 would put me maybe somewhere way down here. So I can connect my dots, right? It's just clear that we've gotten pretty stretched out. We can't fit them all, but I can graph where they are approximately. So it looks about like that. And then again, it is a cubic function. So domain, all real numbers, same with the range. Or negative to positive infinity, right? It keeps growing left, right, bottom up. Okay, last one. Here on the outside, I see a multiplier of 1/2. So this is a vertical compression by a factor of 1/2. So all of my y values are multiplied by 1/2. So I start at the origin, 0, 0. Okay, normally over 1, up 1. But I cut those vertical distances in half. So instead of going up 1, I'm going up 1/2. And then here over 1 would normally be down 1, but again, I'm cutting that vertical distance in half. So I'm only going down 1/2. Okay, back to the origin. Next, I'd be going over 2, up 8. But instead of going up 8, I'm cutting that distance in half. I'm only going up 4. Half of 8 is 4. So then I'm going left 2 and down half of 8, which is 4 right here. And then connect the dots, and we have our beautiful cubic function, just like that. So again, keeps growing left to right, bottom up. So the domain is all real numbers, and so is the range. So negative to positive infinity for both. Okay, so that is our cubic function with just a singular transformation. Could be reflection, could be translation, could be stretch or compression. But for all of these, what's really nice is that the domain and the range stay constant. They are always going to be all real numbers for both. The function keeps expanding left to right as well as bottom up. So we say all real for both or negative to positive infinity. All right, have a good rest of your day.